Let's finish up our discussion on hurricanes by talking about hurricane forecasts. Now, how do you predict a hurricane? Well, the track of a hurricane tends to follow general airflow patterns. We talked about earlier that a hurricane will move from east to west as it follows the trade winds, and then will get caught by the westerlies and turn around. That's a typical pattern. So, for example, here's Hurricane Irene from 2011. Yes, it was a pretty nasty storm. It moved to the north. But notice these forecasts here. Every forecast predicted almost the exact same path. However, Hurricane Sandy, notice that the different forecasts had very different results. Some storms said it would be coming towards Florida, then turn around and then go up to Massachusetts. Another one said it would come north and then head out to sea. Another one said it would they all said they would be a little bit north of where they actually were. So basically, what we use is something called the forecast cone to actually forecast the path of a hurricane. We do an ensemble forecasting, do a forecast with multiple model runs, do a statistical analysis. If they're really close together, there's a fair amount of agreement, you end up getting a narrow forecast cone. In other words, a narrow area of probability for the eye of the storm to follow. Now, that's an important point to note. When you have a forecast cone, let me draw a forecast cone on here for you. You may have something like this for a forecast cone. Sorry about being shaky, but that forecast cone is the region where you're likely to see the eye of the storm. You could still have the storm itself reaching, sorry, I've got that backwards. Woo, try that again. Reaching way out here into these regions outside. So you can still get effects outside of the cone, even hurricane strength winds outside the cone. But the cone itself just talks about the most likely path of the eye. Okay. So we do an ensemble forecast, and from those ensemble forecasts, we do a statistical analysis to create the forecast cone. The narrower the cone, the more agreement you have. In the case of Sandy, there is very little agreement. So I don't know if you remember Sandy from 2012, but it had an absolutely enormous forecast cone because we just did not know what was going to happen with Hurricane Sandy. Okay, once we have a forecast, once we have a general idea of what's going to happen, I should also mention here the track of the hurricane does tend to follow general airflow patterns, like following the trade winds until it gets caught by the westerlies, turned around. But you also have to follow local airflow patterns, like local high pressures. If there were a high pressure here, then it would be pushing the storm off to the east a little bit more. But if you have, say, a low pressure sitting right here, low pressure winds are going counterclockwise, it would have pushed the storm further to the west. The storm would have come up and then moved further to the west because it's following a local airflow pattern. So first guess with a path of a hurricane, you follow the general airflow patterns. Second, you look at local air systems, high pressures, low pressures, upper level troughs and ridges to try and determine where the hurricane will go. Once you have the path initially identified, then you keep monitoring that, and then about between 24 and 48 hours before the hurricane is expected to make landfall, you start issuing watches, hurricane and tropical storm watches. Remember from our forecasting chapter, a watch is merely a high probability that you will experience this weather phenomenon. So a hurricane watch is that within 24 to 48 hours, you are very likely to experience tropical storm or hurricane strength winds. Now, once it hits 24 hours, we have higher probabilities, a better understanding of where the storm's going to go. The probabilities are much higher of our forecast. So when 24 hours hits, we start to issue hurricane warnings where we know they're going to experience hurricane strength winds. It's just a question of when and exactly where the eye will make landfall. But we know that region would experience hurricane strength winds. So for example, here's Hurricane Katrina, where you have a forecasted path would be the blue line. The actual path would be the dotted line. This one we actually did really, really well. And then this region around here experienced hurricane strength winds, so they received a hurricane warning. Over here, they received both a tropical storm warning, meaning they were going to definitely feel at least tropical storm strength winds, along with a hurricane watch, meaning it's possible that they would also experience hurricane strength winds. Let's finish up this video by talking about what's happening in the future. Well, we see figures like these where we have a number of storms all of a sudden increasing, and you have tropical storms, tropical or hurricanes and major hurricanes. Tropical storms would be in green, hurricanes in yellow, major hurricanes in red. You see, oh look, there are more storms now than there have ever been. Well, think of our technology. We're able to detect more storms now, especially in the last 50 years, now that we have satellites that can observe and see these storms. So that's one reason for the increase. Second, our technology has increased so we can better measure the strength of the storms. So perhaps the increased number of hurricanes and major hurricanes is because we're getting better records of the storms. We may have had more major hurricanes back in this time period and just not known it because we had no way of measuring it. That being said, climate does change. We are looking at having a warmer climate here on Earth. What is that going to do to hurricanes? Well, a lot of studies are pointing their fingers and saying, we're going to have more intense hurricanes and more frequent hurricanes. That's most likely what the impact is going to be. But we are still not sure. It's still a very unclear answer. It is a huge region of research.